Tantor Audio, a division of Recorded Books, presents Climate Uncertainty and Risk, Rethinking Our Response by Judith Curry. Narrated by Wendy Tremont King. Publisher's note: in this audio edition you will hear references to figures and tables present in the print and ebook formats of the book. Author's foreword. The major problems in the world are the result of the difference between how nature works and the way people think. Anthropologist Gregory Bateson. World leaders have made a forceful statement that climate change is the greatest challenge facing humanity in the 21st century. While the majority of people are worried by climate change, most are unwilling to follow the call from the United Nations for rapid, far-reaching, and unprecedented changes in all aspects of society. Further, many of the technologies needed to effectively transition the world's economy away from fossil fuels are not ready for large-scale deployment. As a result, there is acrimonious worldwide political debate on implementing climate policies, which, even if successful, have little chance of improving the climate or human well-being in the 21st century. How did we come to be between a rock and a hard place on the issue of climate change? This book shows how the narrow and politicized framing of the climate debate has resulted in an oversimplification of both the scientific problem and its solutions. My personal journey in navigating the climate debate provides insights into the problem and ways forward for finding solutions. Prior to about 2003, it was fashionable in academic circles to be skeptical about the highly confident conclusions being issued in the Intergovernmental Panel on Climate Change (IPCC) assessment reports on human-caused climate change. I became concerned about the way these assessment reports were treating uncertainty and confidence levels in their conclusions. Apart from reading the IPCC reports, I was mostly oblivious to the public debate and controversies surrounding climate change. I inadvertently entered the public debate on climate change on September 14, 2005. The American Association for the Advancement of Science organized a press conference for a paper I co-authored that described a substantial increase in the global proportion of Category 4 and 5 hurricanes. The unplanned and uncanny timing of publication of this paper was 3 weeks after Hurricane Katrina had devastated New Orleans. Our 15 minutes stretched into days, weeks, and months as Hurricane Katrina became a major focusing event for the global warming debate. I was treated like a rock star by the environmental movement. But on the other side of the debate, I was targeted as a global warming alarmist, capitalizing on this tragedy to increase research funding and for personal publicity, and a threat to capitalism and the American way of life. I had lost my bearings during this episode. I took a step back and tried to understand all this craziness and learn from it. I wrote a journal article on mixing politics and science in testing the hypothesis that greenhouse warming is causing a global increase in hurricane intensity. I made my first major foray into the blogosphere, checking in at all the blogs where the paper was being discussed. I landed on the skeptic blog Climate Audit, where the commentators had some good questions about the statistical analyses and wanted to see the raw data. When the IPCC fourth assessment report was published in 2007, I joined the consensus in supporting this document as authoritative. I was convinced by the rigors of the process, While I didn't personally agree with everything in the document, I still had nagging concerns about the treatment of uncertainty and overconfidence. I bought into the meme of "don't trust what one scientist says, listen to the IPCC." I was becoming increasingly concerned by the political activism of people involved in the IPCC and by policies that didn't make sense to me. But after all, don't trust what one scientist says, and I continued to substitute the IPCC assessment for my own personal judgments regarding the public debate on climate change. My perspective on all this changed as a result of ClimateGate, which began in November 2009 with the hacking and unauthorized release of emails from the Climatic Research Unit at the University of East Anglia. These email exchanges between climate scientists and authors of the IPCC were released to various internet locations several weeks before the Copenhagen Summit on Climate Change. When I read the ClimateGate emails, they confirmed concerns and suspicions that I had been developing about politics and personal agendas encroaching on the IPCC assessment process. Attempting to help calm the waters with the climate skeptics, I wrote an essay entitled "On the Credibility of Climate Research" that was published on the blog Climate Audit, where the ClimateGate story broke. Several days later, my essay, an open letter to graduate students and young scientists in fields related to climate research, was published by the New York Times. A big part of my reaction to events unfolding after ClimateGate was the concern that I had somehow been duped into substituting the judgments of the IPCC for my own in my public statements on climate change. I started my own blog, Climate Etc., in 2010, which launched a series on climate science and the uncertainty monster. As people in other fields became increasingly interested in my essays at Climate Etc., I redefined and broadened my academic network to include open-minded individuals from the fields of physics, philosophy, economics, social psychology, law, engineering, management, communications, artificial intelligence, statistics, and political and policy sciences. As I drifted away from the mainstream narrative about climate change, academia increasingly seemed like wrong trousers for me, with its disciplinary compartmentalization, culture of climate consensus enforcement, and freedom of speech issues. I resigned my tenured faculty position in 2017. As a result of the politicization of climate science, I had found that I had lost my love of science in the context of the academic ecosystem. I left academia with the hope of regaining my love of scientific research and its applications. I am now employed in the private sector as president of Climate Forecast Applications Network, CFAN. I am working on new and better ways to apply weather and climate data, weather forecast information, and regional climate change scenarios to support real-world decision-making to manage weather and climate-related risks. Most importantly, I am exhilarated by the lack of political and peer constraints in conducting my research, serving the clients of CFAN, and in my public statements about climate change. By engaging with decision-makers in both the private and public sector on issues related to weather and climate variability, I have learned about the complexity of different decisions that depend, at least in part, on weather and climate information. I have learned the importance of careful determination and conveyance of the uncertainty associated with a prediction. I have found that The worst outcome is a prediction issued with a high level of confidence that turns out to be wrong. A close second is missing the possibility of an extreme event. Simply put, I have skin in the game in terms of my predictions and assessments of risk. I lose clients and damage the reputation of my company if I issue an overconfident prediction that turns out to be wrong. It is this perspective that I bring to the debate on climate change. Integration of a strong academic reputation in climate science, with extensive real-world engagement with public and private sector decision-makers. My transition away from being a supporter of the mainstream climate consensus has led to wide-ranging reflections on the climate debate that incorporates the philosophy and sociology of science, ethics, and politics. My perspective has been developed and shared in academic publications, numerous posts on my blog, Climate Etc., reports to the clients of CFAN, and testimonies presented in U.S. congressional hearings. The goal of climate uncertainty and risk is to stimulate new ideas and broader thinking about the climate change challenge and its solutions. This is accomplished by understanding the deep uncertainties surrounding the issue. New methods of generating regional scenarios for 21st century climate variability and change, and the principles of risk management and decision-making under deep uncertainty. The point of considering these ideas is to increase the range of policy options and enlarge the landscape for decision-makers on issues surrounding climate change. My hope in writing this book is to lay out a path for eventually acquiring wisdom as to how we can best engage with our environment and support human well-being and thrivability while responding to climate change. The climate change problem provides much scope for disagreement among reasonable and intelligent people. This book makes no attempt to arbitrate specific scientific disputes or to prescribe policy preferences. The book is designed to acknowledge and engage with the complete spectrum of perspectives, from people that are convinced to those that are unconvinced by the existing paradigm of climate change. It is aimed at those concerned about the environment, professionals dealing with climate change, and our national leaders. This book was started during 2020, the first year of COVID-19. The scientific and public debates surrounding COVID-19 have become a major topic at my blog, Climate Etc. While the climate debate has unfurled over the course of decades, with COVID-19, we are seeing the same complex interplay of scientific research, politics, and risk governance unfurl on the timescale of months. COVID-19 is challenging how we think about uncertainty and risk, both personally and societally. The comparisons and contrasts between climate change and COVID-19 enrich our understanding of both risks. Judith Curry, Reno, Nevada, USA, August 20th, 2022. Part 1. The Climate Change Challenge. My most fundamental objective is to urge a change in the perception and evaluation of familiar data. Philosopher of Science, Thomas Kuhn. Change in the Earth's climate and its adverse effects have always been a common concern of humankind. The current challenge of climate change is typically formulated as the Earth's climate is warming. A warming climate is dangerous. We are causing the warming by emitting carbon dioxide, CO2, from burning fossil fuels. We need to prevent dangerous climate change by rapidly reducing and then eliminating our CO2 emissions. In spite of the perceived urgency of the problem, and international climate treaties and agreements that were first signed in 1992, global CO2 emissions continue to increase, while targets and deadlines continue to be missed. Most people feel that climate change is a very serious issue. Depending on your perspective and values, there will be much future loss and damage from either climate change itself or from the policies designed to prevent climate change. Conflicts surrounding climate change have been exacerbated by oversimplifying both the problem and its solutions. Acknowledging disagreement is not the same as rejecting climate change as an important problem. In the context of the international treaties and agreements on climate change, both the problem of climate change and its solutions are framed as a global issue. This framing of the central challenge that focuses on reducing global carbon emissions has allowed technical fixes, such as geoengineering and low-carbon energy, to take center stage. This focus has come at the expense of a host of wider visions for social, economic, and political change, particularly at the national and local levels. Part 1 describes how the challenge of climate change has evolved in the context of a complex interplay among scientists, the organizations that support research, government-sponsored assessments of climate research, national and international climate policy, politics, and the needs and desires of peoples and nations in a rapidly changing world. Polarization has deepened in a fog of confusion about what we know versus what we do not know and what we cannot know. A populace that is trying to understand climate change is left confused by international and national policies and commitments that do not seem doable or politically feasible. To assess objectively the risks from climate change and the policies designed to mitigate it, we need to step back from the current debate and broaden our framework for thinking about climate change. Part 1 provides a framework for clarifying our thinking about these challenges. Chapter 1. Introduction. We are drowning in information while starving for wisdom. American biologist E.O. Wilson. Within the public domain, there is a widespread narrative of climate catastrophe if we do not urgently reduce or eliminate emissions from burning fossil fuels. Example quotes are provided here from United Nations UN officials and national leaders. The clock is ticking towards climate catastrophe. Ban Ki-moon, UN Secretary-General, 2015. We face a direct existential threat. Antonio Guterres, UN Secretary-General, 2018. There's one issue that will define the contours of this century more dramatically than any other, and that is the urgent threat of a changing climate. U.S. President Barack Obama, 2014. We are killing our planet. Let's face it, there is no planet B. Emmanuel Macron, President of France, 2018. In the 1990s, the world's nations embarked on a path to prevent dangerous human-caused climate change by stabilizing the concentrations of atmospheric greenhouse gases, especially carbon dioxide, CO2. These efforts were codified by the 1992 United Nations Framework Convention on Climate Change, UNFCCC Treaty. The Intergovernmental Panel on Climate Change, IPCC, plays a primary role in legitimizing UNFCCC policies. The IPCC prepares periodic assessment reports, that are formulated around identifying human influences on climate, adverse environmental and socioeconomic impacts of climate change, and stabilization of CO2 concentrations in the atmosphere. How concerned should we be about climate change? The IPCC assessment reports do not support the concept of imminent global catastrophe associated with global warming. However, a minority of scientists, some very vocal, believe that catastrophic scenarios are more realistic than the IPCC's likely scenarios. There is also a very vocal contingent among journalists and politicians that supports the catastrophe narrative. At the same time, there are other scientists that do not view climate change to be a serious threat. Many of these adopt the lukewarmer perspective, which expects warming to be on the lower end of the IPCC likely range, and do not expect the impacts to be alarming or catastrophic. Some politicians and industrialists reject the solutions put forward by the international climate treaties in favor of near-term economic development. This chapter lays out the contours of the climate change problem, ambiguities surrounding the definition of climate change, what we know with confidence, what we do not know and cannot know, and whether climate change is dangerous. 1.1. What is climate change? Well, brother, you mustn't be too hard upon me, but to tell the truth, I didn't remark the elephant. Ivan Krylov, author of Krylov and His Fables, 1815. A changing climate has been the norm throughout the Earth's 4.6 billion year history. The Earth's temperature and weather patterns change naturally over timescales ranging from decades to millions of years. Natural variations in the surface climate originate in two ways: internal climate fluctuations associated with circulations in the atmosphere and ocean produce exchanges of energy, water, and carbon between the atmosphere, oceans, land, and ice. External influences on the climate system include variations in the energy received from the sun and the effects of volcanic eruptions. Human activities influence climate through changing land use and land cover. Humans are also changing atmospheric composition by increasing the emissions of CO2 and other greenhouse gases, and by altering the concentrations of aerosol particles in the atmosphere. Over the past several decades, the definition of climate change has shifted away from this broader interpretation. Article 1 of the UNFCCC defines climate change as a change of climate which is attributed directly or indirectly to human activity, that alters the composition of the global atmosphere, and which is, in addition to natural climate variability, observed over comparable time periods. The UNFCCC thus makes a distinction between climate change, attributable to human activities altering the atmospheric composition, mainly CO2, and climate variability, attributable to natural causes. This redefinition of climate change, to refer only to human-caused changes to the atmospheric composition, has effectively eliminated natural climate change from the public discussion. The common parlance refers to climate change with no mention of natural climate variability. Any change that is observed over the past century is now implicitly assumed to be caused by human emissions to the atmosphere. This assumption leads to connecting every unusual weather or climate event to human-caused climate change from fossil fuel emissions. The term climate change does not just connote the science of human-caused global warming, but also an entire worldview of society. Geographer Mike Hume identifies climate reductionism as a form of analysis and prediction in which the interdependencies that shape human life within the physical world are correlated with climate change. Human-caused climate change is then elevated to the role of the dominant predictor of societal change. Multiple possibilities of the future are effectively closed off as climate predictions assert their determinative influence over food production, health, tourism and recreation, human migration, violent conflict, and so on. Other environmental, economic, and social factors that influence the societal problems then become marginalized. The ever-expanding narrative of climate change is entraining a range of social values into the proposed solutions. The momentum of the climate change narrative leads to claims that there is a solution to many other societal problems within the climate change cause. An example is social justice in the context of the U.S. Green New Deal. This link acts to energize both causes and leverages the climate change narrative to blame or attack those opposed to the separate cause. Climate change has thus become a grand narrative, in which human-caused climate change has become a dominant cause of societal problems. This perspective was highlighted on the cover of a recent issue of Time magazine, with the title, "Climate is Everything." Everything that goes wrong reinforces the conviction that there is only one thing we can do to prevent societal problems: stop burning fossil fuels. This grand narrative leads us to think that if we solve the problem of burning fossil fuels, then these other problems would also be solved. This belief leads us away from a deeper investigation of the true causes of these other problems. The end result is narrowing of the viewpoints and policy options that we are willing to consider in dealing with complex issues, such as public health, water resources, weather disasters, and national security. The closing statement in Hume's paper? And so the future is reduced to climate. 1.2. What we know with confidence. We understand a lot of the physics in its basic form. We don't understand the emergent behavior that results from it. Climate scientist William Collins. The foundation of our understanding of the processes of climate variability and change rests on fundamental laws of physics, such as Newton's laws of motion, the first and second laws of thermodynamics, ideal gas laws, gravitation, and conservation of mass and energy. These fundamental laws are incorporated into numerous theories of complex processes that contribute to our understanding of climate processes. These include the theories of rotating fluids, boundary layers, and radiative transfer. These theories are widely accepted. The theory of greenhouse warming of the climate system is a meta-theory that incorporates many hypotheses and theories about how components of the Earth system work and interact. Science is a process for understanding how nature works, whereby we explore new ideas to find new representations of the world that explain what is observed. Part of science is to conduct experiments, make observations, do calculations, and make predictions. But another part of science asks deep questions about how nature works. What constitutes evidence in climate science? Scientific evidence is generally regarded to consist of observations and experimental results. in complex natural systems, the epistemic status of observations.
Sample complete. Ready to continue?